Howdy, everybody. Hope you're doing well wherever, whenever you are. We're here for day 8 of Advent to Code 2016. We're in Bunny headquarters, right? EBHQ. That's what they said last time. Anyway, I've been having a lot of fun doing these puzzles. Just keep trying to improve my puzzle solving skills. Maybe find ways to do things faster and find things that I can work on. So, anyway, let's just get started. So this one is two-factor authentication. You come across a door implementing what you can only assume is an implementation of two-factor authentication after a long game of requirements telephone. Okay. To get past the door, you first swipe a key card. No problem. There was one at a nearby desk. Okay. Then it displays a code on a little screen, and you type that code on a keypad. Then presumably the door unlocks. Okay. Unfortunately, the screen has been smashed. After a few minutes, you've taken everything apart and figured out how it works. Now you just have to work out what the screen would have displayed. The magnetic strip on the card you swiped encodes a series of instructions for the screen. These instructions are your puzzle input. Okay, the screen is 50 pixels wide and 6 pixels tall, all of which start off and is capable of 3 somewhat peculiar operations. Rect AXB turns on all of the pixels in a rectangle at the top left of the screen, which is A wide and B tall. Okay. Rotate row Y equals A by B shifts all of the pixels of row A right by B pixels. Pixels that would fall off the right end appear at the left end of the row. So it's wrapping. Rotate column X equal A by B shifts all of the pixels in column A, 0 is the left column, down by B pixels. So we're going right and down. Pixels that would fall off the bottom appear at the top. So we wrap by column. Okay. For example, here's a simple sequence on a smaller screen. Rect 2x3 creates a small rectangle at the top left corner. Okay. Rotate column X 1 by 1. So this one goes down. Rotate row Y 0 by 4. So 1, 2, 3, 4. So these move here. Rotate column X equal 1 by 1. Okay, X equal 1 by 1. Causing the bottom pixel to wrap to the top. Yeah, so these go down. This one wraps to the top. As you can see, this display technology is extremely powerful and will soon dominate the tiny code displaying screen market. Okay. That's what the advertisement on the back of the display tries to convince you anyway. There seems to be an intermediate check of the voltage used by the display. After you swipe your card, if the screen did work, how many pixels should be lit? And then here's our puzzle input. Not a lot of instructions, but okay, so how are we solving this? Obviously, I mean, I think we want like just to have like some kind of empty thing with it on or off. I mean, we can use a bool for on and off. We just have like a vec. The hard part would be figuring out how to like rotate. Like for an instance, I thought I could use a vec deck. That would work for shifting rows like this, because like you could imagine just like for whatever value you're given, you like pop off this, put it in the front, pop off, put it in the front. But that doesn't work for columns, unfortunately. So although you could You could use a vec deck. You could get a column and, sorry, whenever you call rotate row or column, you like find that column, put it in a vec deck, and then perform the, pop back, push front as many times as you want to. What kind of rotations are we doing? 2, 3, 1, 2, 3. There's a 10. Oh, there's a 30. Here's a bunch of large ones. The only other thing that's going through my mind is you could potentially, so do some kind of popping and pushing. If you, regardless of where you are, you could still do a rotate where you like, you don't have to use a vec deck. You could have, like, so say you're doing this rotation right here. What you do is you'd start at the bottom and store what the bottom is, and then you like go up one, put it down, go up one, put it down until you get to 0, and then when you're at the 0, you get the stored one, and then you just do that a bunch of times. But that seems a little inefficient when you're doing like, by 30 or 50 or 70. Again, that's relatively small, so maybe it doesn't matter. Maybe you just do that. I guess you could do math too. I've been so bad at the math ones. I was trying to think, is there a math way to solve this? You could create like a temporary vector of the current values. So take a snapshot of what it currently is, and then if you're at position 0 and it's moved 10, you do like 0 plus 10 modulus the height, the maximum height, and that tells you where this hash should go. And so you place it in the thing. Okay, so I think that would work. That's probably faster. You still have to alloc, one vector length of the thing that you're moving around. That's probably easier than doing rotations, like pushing off, putting back, or doing the thing like this. So maybe I'll try that. I haven't even thought though, like what I also need to do is be able to parse these. So get these values. Again, I think I can probably use the split by space, and then use matching to get that done. And then, so I get a bunch of those. And then I'll probably have some struct where I maintain the vec where I'm at. And then be able to like apply these things to it. Okay, let's try that. So what? Yeah, how will we do this? Well, let's make an enum for an instruction. And it's going to have rect usize. And then we're going to have rect. Rotate row. and we're going to give usize. Like, I think we're using usize all the way here, right? None of them are negative. And then rotate column by usize. And I was just going through my mind. Are there going to be more instructions for part 2 or what? Anyway, so we rect A by B. So, okay, so there's only 3 of them. So let's write a parser for these. Impl instruction fn parse input stir will give us a self back. And so we want to input split white space dot collect so then we match on parts. And what did I do there? Okay, so we have rect AXB. So I need to, this one is going to be like let AB equal dims dot split once. Isn't it split once? What was that called? I used it just the other day. I can only split once on a stir. Oops, what did I do there? Oh, there it is right there. Option stir split once on a string. So this should, so it'll be rect a dot parse dot unwrap b dot parse dot unwrap. Does that work? Oh, okay, so I have uncovered lines, but that's okay. So I can do panic here. Okay. So now I need to do rotate row and column. Rotate. Row. What is that? The row by count. Okay. So we do this to get the row. And then it will be self rotate row row.parse.unwrap. Do I have that right? Rotate row. Yeah, okay. Oh, this is not an X, it's an equals. So now I just do the same thing with column. So that should be the parse. So my input is going to be a vec of instruction. Input lines map instruction parse dot collect. Okay, so now I have my input. Oh wait, what isn't like here? Rotate column. What is this saying? Oh, it's just that they're not used. Okay. Let's add a debug and we'll print them out. Okay. Oh, I was gonna say, can you do this? Does this work? Maybe I had to spell it correctly though. Okay, maybe you use this if they impl the thing, but because this one doesn't. Rect11 rotate row 07. It looks like it did it. Okay. I think that looks correct. So we're parsing okay. So now we've got our instructions. So next we want to what do we want to do next? We want to parse we want to have a board that we can apply instructions to, right? So struct board, or what is it called? A screen. So the pixels are a Actually, could I just, I know the size. It's 50 by 6. Can I do something like this? Const width. It was 50, right? Can you tell that I worry? Yeah, it seems like that should work. Do I need to initialize that? I need to set them defaults because they're off. Okay, so now we have rect AB. Maybe we do helper functions and then we do a parse or an apply. So we have fn rect, and you give me width height. I guess I need oops, a mute of myself to do this. But so it would just be like for how does it work? At the top left of the screen, turn on all the pixels in a rectangle at the top left of the screen, which is A wide and B tall. So I do start at 0. So for 0 for w in 0 dot width dot max width, and then for h in 0 dot height dot max height. So like this will prevent us from overflowing, and then we just do self dot pixels width height. It's actually the other way around, right? It's height width equals dash, right? Oh, true. We could use characters. I mean, bool is fine, I guess. Okay, so fn rotate row A by B. Self the row is a U size, and the distance is a U size. Okay, so this is the one where I think we just grab the row, we clone the row, and yeah, so here's what I'm thinking. Grab row, clone row, do math to figure out where each should go and place it in myself. Okay. So let old row equal self pixels. What row am I? It would just be row, right? So this is my row. And so like that. What doesn't it like about this? What is this thing? Oh, I don't need to clone it. It'll just copy. Okay. So now I'm gonna go for I in 0 dot dot old row dot lane. So for each of the rows, I'm gonna get a new position. Let new position equal, and it's my current position plus the distance modulus the width, right? And then I'm going to, so now I'm going to say self dot pixels row new position is equal to old row I, like that. What doesn't it like about this? Oh, it's because I can do I be in old row dot iter dot enumerate is what I think it's mad at me about. Does that seem right? So I grabbed the current row, and now I'm going to go through that row, and then I'm going to place it in my thing where it should be, which is myself plus the distance divided by the width. Okay, yeah, I think that's right. So rotate columns. Oops. Is going to be the same, except grab the old column. it's not going to be like this. It's going to be self.pixels.iter. Excuse me. Map. So for each of them, I'm going to get a row, and I want to return the rows column dot collect, like that. Now I'm going to iterate them, but it's going to be new position column modulo height. Yeah, this definitely feels easier. Like I was trying to think as I was writing this, can I like, if I had a vec deck and just like push pops, I don't know that that's actually faster. This may be the best of the 3 ways to do it. But okay, let's see. So now we'll do fn apply self instruction, and then so we'll do match instruction, instruction rect width height, and that will be self.rect width height. Instruction rotate row count will be self.rotate row I guess it's called distance. And we'll do the same but for column. What doesn't it like about these? Oh, I need to like do this, huh? Or wait, it's other way, huh? Like that. So now I can do what am I returning for part 1? The number that are turned on. Okay. self.pixels.iter.flatMap. I actually don't even have to flat map. I can just map it to something like that. Fiddler. Oh, I need to do it twice. Okay. He'll probably have to be mutable. And then we need to input dot iter dot for each I screen dot apply I, and we'll return screen dot on that. Oh, I guess I already had, it's already a pointer. $300 sound right? It is not right. Oh, that yes, that suggests all of them is on. Hmm. They're all set to false. Oh, this doesn't work. It's not max, it's min. Is that my failure? $128, is that better? Got it. Okay. Yeah, that wasn't too bad. Let's move on to part 2. You notice that the screen is only capable of displaying capital letters. In the font it uses, each letter is 5 pixels wide and 6 tall. After you swipe your card, what code is the screen trying to display? Okay, I think we just print it out then. So should we impl display for screen? Let's see, for I want to do height first, right? H in height. This, and then I want to do 4 width and 0 width, and then we'll do I feel like it's is it right? How do you impl display? Yeah, right F this thing. Okay. So if we do right, self dot pixels height width, and then here we'll right line like that. And then we'll just right line one more time. What doesn't it like about this? Clippy doesn't like me not catching errors. What is this? Doesn't like that I do an empty one. Oh, I'm not actually printing it in part 2. Okay, so I need to do the same thing for part 2. Should I return the string? This is like a weird one, but yeah, maybe I do. So I do like this. Oh. And I don't have this done. I should probably stop doing that. Oh, they're all trues and falses. LOL. Let's change it to a car. Start with off. Set to on. I don't think anything else has to change, right? It does. That? Ooh, it's hard to see. I'm going to stretch the screen and it's going to look weird, but you probably can't see that. Maybe I bring it over here for you to look at. So it's EOARGPHYAO. I think, if I've done it right. EOARGPHYAO. Oh, that's the right answer. Okay, let me fix this really quick. Okay. Yeah, so that one wasn't too bad, right? I have spent a lot of time on this. Was it just me trying to impulse stuff and figure it out? Yeah, I mean, this felt good. I had to write it by hand and I kept checking back and forth. So maybe make sure I'm like zen, ready to go whenever I'm solving a problem. That's hard if I'm thinking about this year doing it competitively, because I think it opens like at 10 p.m. my time, which is like an hour past my bedtime. I wake up really early, like too early for most people. So I go to bed around 9. I'll have to change that though for December, I guess, if I want to be competitive. Who knows? Maybe I won't be able to. So this is a little annoying that I'm getting these, these warnings. Like it's saying like, oh, you have an empty string. Does this clicking on it work? This lens when you write up print. Why is this bad? You should use which is simpler. Oh, I can just remove it is what it's saying. Like that. Okay. And it runs really fast. Right? We're in the microsecond range. I think this is what probably my solution is faster. My guess would be this is faster than any of the other ways. I'm not even inclined to try them. Like the way that I was thinking is to make this a vec deck, and then just for distance, pop push, pop push. I mean, maybe we could try it on rotate row to make sure it still works and give you an idea of what it is, but I don't intend to keep it. So you'd still say let old row equal self dot pixels row dot iter dot collect vecdeck. Like this. And then it would just be like a I guess this is mute. Oh, but you're gonna have to put them back in. I mean, I guess you can still do that. So it would look like, oops, I have an error here. It would be old row dot push front old row dot pop back dot unwrap, something like that. Yeah, parens are unnecessary. It probably doesn't like this because I borrow mutably and then immutably. And so I believe this has like the net. It actually doesn't. That is not the right answer. Oh, I don't change it. Self dot pixels row was old row. I mean, old row is named poorly. I do this. You do have problems going back and forth. Oh, it's probably because I'm using an array here. Huh. Okay. It would look something like this, presuming I'm using a vec. But again, I'm not a fan of this way. So I don't know. If anyone knows why this watch thing doesn't work all the time. Let's see what else. Grab row and clone it. Yeah, I don't think I would change much here. I mean, I guess I can put this in here. So doesn't feel like it helps much. But I mean, yeah, there you go. That helps too. Oh, I guess I'm not using VecDeck anymore. Okay. Anything else I'd change? The actual logic is fairly simple, so I think the answer is probably no. I have a little printer that prints out all the answers. This one's going to be ugly. I mean, that might be something that's interesting. Could you determine what the letter is and then have it be an actual string? Who knows? Feels like a future me problem. Yeah, maybe if you have some solution, I'd love to see it if you have some way to like turn the hashes and dots into strings. That would be fun. Given that you know it's a 6x5, you could probably infer what it likely is. You could pass it to like a machine learning thing that knows letters and can guess them based on those things. I don't know. Anyway, that's the only thing I can think of. So anyway, this one was a fun one. Not too tough, not too bad. I'll submit this. Let me know what you think, what you'd change, how you do it differently. Otherwise, yeah, we'll talk to you next time. Bye, everybody.